Hi, everyone. Thank you for joining us today for the first CLF webinar, CLF BC webinar of the year. I want to start off by thanking our speakers, Ben, Jeremy, and Sharon, for joining us today, making the time to do this, as well as the Forestry Innovation Investment for financially supporting this webinar today. We have some other people that are part of the team that will join in the Q&A that will be able to contribute to responding to your questions. So for today's topic, we will be going over the Discover Montessori project. This was an award winning project for the 2023 BC Embodied Carbon Awards. And so today you're going to learn more about this project, what they had done to get that kind of recognition. Okay, so in case there are some of you who are new today to the CLF, CLF BC is focused on reducing emissions, the embodied carbon emissions. And so also I'll introduce myself as the new program manager for CLF BC. And in 2022, CLF became the part of the ZEEC, the Zero Emissions Innovation Center, family of programs alongside ZEBEX, the B2E, so the Zero Emissions Building Exchange, the Building to Electrification Coalition, and also the retrofit program that's in development. And I should have maybe threw this in here, but there's also the Near Zero program. And just at a high level, when we talk about embodied carbon, what we're referring to is the carbon that is the emissions that are associated with the extraction, the manufacturing, and the production through to the construction, the maintenance throughout the operational life of the building, and then to the end of life when there's any demolition, deconstruction, and waste processing of the building. And so when we look at all of those stages, that's what we refer to as whole building life cycle assessment or whole building LCA. And why is this important? Well, the embodied carbon emissions make up 11% of the global carbon emissions. And so, as we see efforts being made over the last several years on reducing operational carbon, we're realizing that time to also focus on embodied carbon, as this is carbon that's locked into the building before you're even starting to use it. And so how can we find interventions to reduce that carbon? And so the CLF is responsible for for what we're trying to achieve at CLF, rather, is to build this network of other folks who are trying to focus on this, bring everyone together to learn and to help influence how codes and policies can evolve to make sure that we are addressing this. And so CLF BC is a part of, is connected to a global network of, CLF hub. And in this map, this is just showing the ones in North America, but there are also hubs in Europe and Asia as well. And so a couple more things I'll say is part of our network goals, collective action. We want to share our learning and problem solving, lessons learned. We want to remove those barriers and help us go further and faster together. And some areas that we have, some activities that we include are embodied carbon exchange, where you guys can come, bring, if you want to share about, it's quite informal, and it's just an open discussion to talk about some challenges you might be facing. There's also the embodied emissions peer network, and that's for local governments and staff to kind of figure out what the common goals are. And then there's the embodied emissions research network, and that's for those of you who are doing some extra research, if you want to share knowledge, collaborate on initiatives with others in this group and that share this interest. And so last I'll say is, if you're wanting to learn more, please do visit our website, clfbritishcolumbia.com. It's a nice way you can refine your search to find other past events and webinars that we have. For example, this webinar today will be uploaded. We have some, if you want to search part 9 or part 3 buildings, it will show you what we have, so it can be refined that way. And I guess I'll pause here and I'll pass over to Ivan Lee, who is building science engineer and principal at Morrison Hershfield. So Ivan.
Thanks, Stephanie. So before we dive into the project, I want to give a bit of a context and information about the Embodied Carbon Awards. Just consider this as a bit of a pitch for this year's. I'll try to keep it brief and not go too long. But for those of you who may not be aware, the Embodied Carbon Awards are basically an event for us to showcase embodied carbon reduction efforts in building projects within the building industry. The awards are meant to inspire, educate, celebrate, and foster community within this area. And of course, a little friendly competition never really hurts, right? So last year we had our first set of awards, and we've had over 30 entries spread over 3 different categories. We had judges to deliberate between the different submissions, and then at the end we ended up hosting a big event, awards night event down in downtown, and you'll see some of the photos here. So a lot of people turned out, those that have submitted nominations, as well as others within the industry. So it was a great industry event, and really really inspiring to see so many people turn out in the interest. So between events, next slide, Stephanie. So we're also doing the awards again this year. And we've actually expanded the scope from 3 categories, which were organizational, commitment to change, large buildings and small buildings, to add 3 other additional different categories, including public sector leadership, strengthening the practice, and commitment to circularity. The organizational commitment to change recognizes organizations who are showing exemplary leadership within commitment to change to reduce embodied carbon and kind of changes within their practice. The public leadership, sector leadership is likewise similar, but it's more for BC-based governments, BC-based non-for-profits, regional districts, and public sector organizations that also are showing leadership in reducing embodied carbon. Strengthening in practice is also very similar on the same vein, but this award recognizes individuals who are also championing embodied carbon. So maybe that one specialist in our office is doing really in terms of leading the way within your organization. We want to recognize those individuals as well, and that's going to be a nomination-based award. And then, of course, we've got our large buildings and small buildings, which are basically awards demonstrating or showcasing buildings who have demonstrated leadership in exemplary performance in terms of reducing embodied emissions in their construction and design. And then the final new award is the commitment to circularity, and this is the one where we're awarding basically initiatives that are showing exemplary kind of advancements in embracing advanced circularity and circular concepts. Submissions for this year's awards are due February 5th, so that's coming up, and the awards will be held on April 18th. Yeah, so now let's get into the task at hand here, and kind of summarize what we saw as far as from the judges group in terms of for this project. Overall, the judges were really impressed by the amount of reductions and the tasks done in terms of achieving this high level reduction. The overall project achieves a 42% reduction in embodied emissions relative to the baseline. And this was done through alternate construction methods and concerning alternate materials and really concerning a whole wide range of things. The team really demonstrated really good judgment or basically a lot of flexibility in their design. The team considered multiple concepts for structural and building and architectural layouts, as well as materials and systems, and kind of used that, and through that process helped narrow down to this really low embodied carbon design. So before we jump into talking about this, I'd like to launch a poll to see who else would be interested in showcasing or applying to the awards, and perhaps seeing if they can do something as good as this, or if not better, for this coming year. So Roberto, if you could launch that poll, that'd be great.
I'm just going to share the results for this poll. I think I have to do that before actually launching the next poll.
Oh, okay.
results of that's a bit of our audience profile right there. And then I'll proceed with the next poll. Just a bit of a trying to figure out how many of you are actually going to be potentially applying. And here it is, second poll.
Yeah, I'll add that it's good recognition. It's a really good industry event. There aren't a lot of events similar, so just even, you know, if you're doing something, get yourself out there and just share, right? So highly encourage people to engage with us.
We can move on to the presentations, Ivan. I think I'll share the results of that poll a little bit later, potentially.
Sounds good. Yeah, so we'll throw it off to Ben.
Okay, well, thanks, Ivan, and thanks, Stephanie and Roberto and CLF, and also thanks to our client, Discover Montessori, and to our entire consultant team that included Introba and FastNep and ourselves, Checkwitch Poiron Architects. I'll just share my screen here. So we are an 8-person firm with offices in Vancouver and Nanaimo, and we do projects on Vancouver Island and on the mainland of Vancouver and the islands in between. And we design a wide variety of projects, including educational facilities like Discover Montessori. The project is a 10-classroom farm school, Montessori farm school, located on the agricultural land reserve just outside of Nanaimo. Like many clients, this project, the client wanted to make the project as sustainable as possible, but had to do so within the limits of a tight budget and a tight schedule. And this was compounded by the fact that it was constructed during the post-pandemic era of volatile cost construction escalation. So maintaining, and I'll just kind of chat about this as I'm going through some slides which show the project. Maintaining the sustainable criteria and the design became challenging over the course of the project. In my opinion, I think that's what made the project kind of interesting, because in my opinion, addressing this challenge of maintaining the sustainable criteria while also trying to keep it cost effective, it makes this project maybe relevant because as to the industry, because I think that this client didn't have the pocketbook or budget to just throw whatever they could to maintain that criteria. Many sustainable projects that I see promoted or published often appear to have budgets that are big enough to do this. And this project is different because it's more aligned with the per square foot cost of construction of a normal project. And if we as an industry can implement low carbon construction in a cost efficient way, then we have the ability to collectively affect greater change. However, there are a couple core ideas that were built into the project that help keep the idea of sustainability, regardless of the challenges of tight budget and schedule. Like I said, oh, I'm just trying to, gotta close this so I can advance the, I'm having trouble getting the poll off the screen, guys.
I'll get rid of it.
Yeah, thanks. Oh, okay. Sorry about that. So like I said, it's a Montessori school. And for those who don't know about Montessori, a brief introduction. Montessori education was developed by Maria Montessori around the turn of the century. And she was an Italian educator and physician who developed a system of education that aims to develop a holistic understanding of the interconnectedness of all things by teaching children to appreciate and care for the natural world and help them understand their role in creating a better world. This holistic perspective aligns with the principles of sustainability and the consideration of the long-term consequences of our actions and on the planet and future generations. And while Maria Montessori didn't contemplate the idea of modern sustainability, the core principles and values of Montessori education can be applied to foster a sustainable mindset that promotes sustainable practices among children and adults by nurturing this sense of interconnectedness, respect, and environment and global citizenship. The other thing to speak about when speaking about Montessori is there's a set of design guidelines almost that comes along with Montessori schools, and part of that is this idea of minimalism and reduction and connection to the natural world. And I think those really align with many sustainable initiatives. Another thing that the project had going for it was the commitment of our clients, Karen and Cynthia, to these principles, to these goals. And I don't know how many times I heard them say that they didn't want any plastic, fantastic, outdoor furniture and stuff like that. And I think part of that is connecting the students with the natural world, but it's also about creating an environment that doesn't distract. But the other thing that another kind of core part of the brief was the project is on the agricultural land reserve. I don't know if anybody here has tried to rezone the agricultural land reserve. It's not for the light of heart, and it's not an easy thing, nor should it be. But one of the things that came along with the rezoning was a mandate for the project to be light on the land, easily returnable to farm use. And it was actually specified directly that the project could not be slab on grade. So, when I read this letter, it was around, 3 years ago, and it was the time that I was, becoming aware of the construction industry's influence on the carbon footprint. And, Anthony Pax talks about our blind spot as an industry. So, understanding the concepts or the principles of Montessori schools, this mandate from the ALR, the support from our client, and the rezoning telling us that we couldn't have a concrete slab on grade, it helped kind of define the criteria of going after carbon, because I think, as many people know in this webinar, that concrete is a big offender, and when it comes to carbon emissions. So again, the project is a 10 classroom school that consisted of an existing building and a new building. You can see the existing building in the back that was renovated. And, again, there's a fundamental concept about the connection of the classroom to the natural or outdoor space. And the project was designed around that idea. So there's always a connection between the classrooms and some kind of outdoor space that connect to it, that again connects to the greater, agricultural piece of property in which the project was located. So we went, again, there was many things that we wanted to do with the project. I think that, some of them we achieved, some of them we didn't, and we kind of had to go along with what was happening with the project, because, as I mentioned, it was constructed during this time of rapid cost escalation. It was had to be done on a cost-efficient budget. So there was these are some of the things that that we went after in terms of operational embodied carbon. And maybe during my talk, I'll speak about some of the things that we had to modify during the course of the project. So, as I said, we weren't allowed to do a concrete slab on grade. So some of the systems that we looked at were a helical screw pile solution, and we also looked at a concrete pier foundation. I think the team had always kind of assumed we were going to do helical piles, but very early in the project, we did an assessment, and that was led by Yuri Kulikov of Fastnep and Introba. analyzing not only the carbon footprint of these different structural solutions, but the cost. And once we had that data, surprisingly, we went with concrete pier foundations because, as you can see, the difference between the two was not that great. But coupled with the cost, we went with the concrete pier solution. Along with that, of course, came wood retaining walls. So wood retaining walls isn't really something that I was totally comfortable with as the architect who was taking responsibility and signing off on the project. But regardless, we implemented that. So you can see the concrete piers here and where we had to create these wood retaining walls. But what that did, it created this cavity underneath the building that we were able to employ for different things. So here's a section which shows the assembly, the different assemblies that we employed, the roof assembly, wall assembly, floor assemblies. Again, some changes were made during the course of construction to suit the timeline and suit the budget. For instance, we had a service cavity in the ceiling that we had to get rid of during construction, just because it was less expensive and faster to not do it that way, but it came at the cost of less air tightness. Some of the insulation we had specified as cellulose, it had to go to fiberglass bat. But we used that cavity underneath the building to integrate the mechanical system. And the mechanical system itself was actually remarkably simplistic. It used baseboard heating. We had larger goals at the start that we had to pare back. But even keeping the system, very kind of straightforward, and it was an electric system, we were still able to maintain that carbon criteria. We also used the area underneath the building, underneath the decks, for rainwater catchment. Sharon McGeorge of Introba did an amazing job of designing the rainwater harvesting system for both not only for use in the school, but also for the irrigation around the property. And Sharon will talk about that later in the project. And then we also, designed the building to try to incorporate daylighting as much as possible, not only in the classrooms that were on the exterior building, but trying to bring it into the interior of the corridor of the building. And so this was something that not only helped with the kind of feel and the vibe of the building, but also helped, reduce the electrical load, and we used some of the heat gain in a positive way. Some interesting things, materials that we used in the building. We used a reclaimed Douglas fir flooring. It came from a warehouse in Victoria. It was planed, sawed, and sawn and stained, and then used as cladding on the project. And you can see some of it here. It's a really beautiful product, and it was provided by Heritage Lumber. And then also on the interior of the building, there were timber tiles. Timber Tiles is a company out of Port Alberni that diverts waste from the hemlock forest industry, and takes that scrap and turns it into tiles. It's a really beautiful project, but it's also an example of where we had to pare back. We wanted to have that much more extensive, but we had to limit it. But still, I think it was really effective. And these are just some more.
Sorry, Ben. Just one small point, if you can go back to the previous slide. Oh, nope. One more forwards. Right on the side of that image, just as a fun note for everyone, is the 2023 Embodied Carbon Award.
Yeah, and I think that speaks to our clients' commitment to this, right? They're proud of what they did, and they should be. I have a lot of admiration for our client. They kind of walk the walk. So, yeah, and that I think that kind of sums up my part of the presentation. And I'll turn it over to you, Jeremy.
Amazing, thanks. Can I get confirmation that people can see my screen? Awesome, cool, thank you. So yeah, thanks, thanks Ben, Stephanie, Ivan, for setting all of this context up. So it was a project that, I'll take a second. Hi, I'm Jeremy. I'm on the sustainability team at Introba, and along with my teammate Sharon, who will be presenting a little bit further into this deck, we were involved in the mechanical, electrical, energy modeling, and carbon part of the project. So it was one that we were incredibly excited to get to support so much on. So like Ben was saying, how significant amounts of of embodied carbon was avoided was one of the main changes. Was simply, what a slab on grade baseline would have been. So that design was developed. This was by Yuri at FastNet. And then it was also looking at, well, this is the design that we're working with today. So what the differences in how that is experienced is actually not that drastic from a student's point of view. It would be the difference between these two images. And then just because I know helical screw piles aren't common, one of the other things that we considered early on, basically giant screws in place of the foundation. But screws that are large enough that you need an excavator to act as the screwdriver. So if we're thinking about the logic of the basic logic of how embodied carbon is calculated, it's basically looking at our high-level material quantities, applying embodied carbon coefficients per material, multiplying that together and adding it all up. So one of the simplest ways to have a huge impact on the result is simply to use less material up front. And the difference between, and that's really one of the primary differences between those two foundation options, was just simply the volume of material needed. But that wasn't actually the only difference. One of the other differences was the insulation type that would have been used in each case. So a conventional slab on grade design will generally be making use of extruded polystyrene, XPS, and a insulated TGI cavity, as Ben mentioned, we used fiberglass and or mineral wool in certain places. One of the other things that was a separate part of the conversation, but also something that we took the same lens to, was looking at the roof design. So early on, these were some of the options that were under consideration. Option one was TGI rafters with blown-in cellulose, and the other option was 6 inches of XPS. Now, again, going back to how the calculation is laid out, the key thing here is not so much changes in material quantity, but those materials will have different embodied carbon coefficients. And I think this is really nicely laid out using the graphic from Builders for Climate Action from the Embark report, which shows these materials as a category. We know that in reality there's data points along each of these lines, but really the key thing was moving from either one of those insulation materials that are kind of in the red zone of this graphic, and that's even considering the newer HFO based formulations of XPS, to the more BAT based, closer to, I would say, products that are not carbon sequestering but definitely lower emitting. So, but those weren't the only things that we looked at. So one of the other things that was looked at was looking at alternate window frame types. That one is a tricky one to analyze on the timeline that projects need, because not only will it affect the LCA model, but the choice of window frame generally will have a substantial impact on your energy model as well. And so there's a real trade-off, just like there is with insulation, as to, well, maybe you can get the lower carbon material, but it doesn't help your energy model. And so what's your net carbon impact at the end of the day? I will say that is a conversation that I think as industry, even when we're working internally with Introba, and I'm working with our energy modeling team that sits right next to me, it's one that we don't have the process totally down yet. I think we're getting there, but that is probably a consequence of having two separate targets. One of the other things that we looked at was using wood instead of the steel for the entry canopy columns. This was a lower impact only because of the relatively small volume of material that those columns are over the overall, but they ended up choosing wood for this, which is fantastic. Ben was mentioning that the reclaimed Douglas fir cladding was used. We ran into software limitations in trying to model this. And also, at the time, this was a couple years ago, there wasn't things like the City of Vancouver guidelines that gave us much clearer processes for how to model reclaimed materials. So we were conservative, and we didn't take into account the savings from that. And then those timber tiles, while fantastic, and I was really excited by them, ultimately they were outside of the scope of the LCA because they're an interiors material. And we were following the zero carbon standards modeling procedures, and they require structure and enclosure to be included. So talking about embodied carbon emissions, as Stephanie said, the emissions related to production, maintenance, and end of life. So we used the Athena impact estimator for buildings for the Discover Montessori project. We modeled a 60-year life, so basically projecting those emissions out until 2080. And we modeled the structure and enclosure. So by mass, and this is the actual design, not the concrete base slab baseline, the actual design, even considering the reduced amount of material in the concrete pads, this is still the approximate breakdown of material in the project. So the foundations dominated by concrete and rebar, the columns dominated by concrete and rebar, and then the floors, roofs, and walls are mixed by mass of materials. But when we look at the embodied carbon by those same building elements, and hopefully this image is coming through cleanly, and looking at it now, and the colors are a little hard, but the columns and beams and the foundations are really less than 20% of the total emissions, even considering they're probably 40% by mass. And then just looking at the scenarios that we had run, so the yellow line here is the actual case. So the impact of deleting that concrete slab, those retaining walls, the strip footings, and the XPS was really to drive those blue, those emissions down. Now that led to minor increases elsewhere. So getting rid of the sub-slab insulation really increased the floor insulation, or moved those insulation emissions from the foundation element to the floors, but it went up a negligible amount. And then that columns and beams element goes up just a touch, but really that's more shifting it from the walls section. Because basically, what's the length of a column before it counts as a wall? And then finally, the impact of just switching that roof insulation type was that third drop over here. And then just again, remembering that wood is the primary construction material of the majority of the building. So looking at the results by life cycle stage, it's overwhelmingly module A1 to A3, which is related to material production and manufacturing. A4 and A5, which are construction transport to site and construction processes themselves, is pretty minor. And then the other major piece of this is replacement. So that's projected, a new roof in 30 years, maybe new windows in 20 and 40 years. And all of that comes together to sit at about 137 kilograms of carbon dioxide per square meter per 60 years. Now that is the A to C definition. I am going to heavily caveat this and don't report this as part of your core results, but the tool also calculated the biogenic emissions, which the newer versions of Athena's tool has stated that it'll be moved out of module D and into, I think A0 or A1 bio. Ivan can probably correct me on that. I haven't finished reading that one in full detail, but that is the emissions and really the carbon dioxide equivalent stored within the wood in the building structure. So we're not taking credit for that because we don't have full confidence really yet in the forestry industry's ability to trace things from tree to lumber. I hope we get there soon. But one of the other things, just to put that intensity in context, is the best threshold from the CHBC zero carbon standard is less than 240 per year, so well under that. And Sharon, I know I'm trying to speed up, so I leave you all your time. So thinking about operational carbon emissions. So like Ben said, there's a number of elements that came together here: a high performance envelope, high performance glazing, but in addition to good windows, also a low window to wall ratio. So that means that there's a higher, R value for the effective enclosure. A low vertical facade to area ratio, and then a suite of strategies intended really to recover waste heat, to make use of internal gains, internal heat gains, and solar gains, and reduce lighting demands, and then also using CO2 sensors to help target ventilation when it's needed, not just leave it on all the time. All that comes together to give us a TEDI and a TUI, a TEDI of 27 and a TUI of 82.8. But to think about operational carbon, we got to convert energy to emissions. So to do that, we basically apply the BC electricity emissions factor. And that gives us basically 0.91 kilograms of carbon dioxide equivalent per square meter per year as an annual emissions value. So emitting just over 1,000 kilograms of carbon dioxide per year and projecting a lifetime emissions of around 62,000. And just for some context, again, looking at the zero carbon step code for a new condo building, the moderate step is a limit of 7, and the zero step is still 2. So we think we're quite proud of this performance. Now, bringing it together, this is the whole life carbon story of the building. The lifetime emissions are around 223,000 kilograms of carbon dioxide equivalent, and a lifetime intensity of around 196. One of the key things, though, to sit on for this slide is that the carbon that's been emitted in the structure and enclosure of the materials, just in modules A1 to A5, is almost 2 lifetimes worth of operational emissions, so 120 years. So to put that another way, that's maybe 6 generations that will need to pass through the doors of this school until the operational emissions match the embodied emissions. So that's maybe the great-grandchildren of the students there today. But that is a success. That is only to say that we have tackled the biggest issue in carbon for buildings. Historically, operational emissions have been dominant. They have been, I think, buildings in the past have had an operating GHGI of 20. So we are proud of projects like Discover Montessori because it's really showing that we've solved the operational problem. And as an industry, we should be turning our attention to the embodied emissions of our buildings. And then it's low carbon aspects we're not even considering. So I'm going to go really fast here, Sharon, I promise. But a 2,000 square meter building of a certain type sometimes can have as much mass in its HVAC systems as a blue whale. And while the structure of the building will hopefully last, hundreds of years, well beyond that 60-year model lifespan, we're pretty confident that the HVAC systems will need replacing in 20, 30 years. Most of the HVAC systems are metal, and as we're seeing more and more demands for cooling, they're using more and more refrigerants in heat pumps. So going back to that initial image, we're also incredibly proud of the, even though we aren't assessing the embodied emissions of the HVAC system for Discover Montessori, we think the fact that it is relatively scaled down compared to what it could have been is something to celebrate. And then just to note, the operational carbon emissions are not technically just tied to energy use. They're also associated under module B7 with water use. And while it's uncommon for us to be thinking about it in North America, module B7 does get accounted for in LCAs that are submitted to the Australian Green Star program. And Sharon, I'll hand it off.
Thank you, Jeremy, for all of that. Jeremy left off with a note about water. Now I'm going to speak about the very interesting and kind of forefront water system that Discover Montessori has ended up with. And I was lucky to be the lead designer on the potable water system for this project. This won't be addressing specifically the carbon side of things, but it will just be a quick snapshot sort of to pique your interest and get the idea of what water system is possible. So Discover Montessori is on outside of the city limits and it's on ALR land. Because it's outside of the city limits, it does not have a municipal water source connection as an option. And going into this project, Introba had the design criteria to provide a rainwater catchment for irrigation and a well water treatment system, which I was heading up. Now, as we progressed through the project, there was some analysis done on the aquifer, on the availability of water. And because in that area, there are a lot of houses using that particular aquifer, the drawdown water tests resulted in letting us know that actually this aquifer is overtaxed and that water is not available. So Discover Montessori came back to us saying, is there another option? Could we use rainwater as potable water? And I said, yes. Now, in British Columbia, in 2020, the government issued its first design guide for commercial buildings to use rainwater for potable use. Since that time, there has only been a handful that have made it through the design process and actually successfully had a certified rainwater harvesting for potable use system. And this is one of the systems that has been implemented. So we went at that point, we're partway through the project and we have to make rainwater work. There really wasn't another option out there for this project. And so we did a bunch of number crunching. You can see on this graph, the blue background is sort of an average water rainfall. You can see the cistern levels over time that we modeled, or the tall dark blue lines. Diverted to overflow. Now in our model, we kind of assumed no overflow, but in reality, rain sometimes comes all at once, and there definitely will be. But on the baseline model, we aim to not have overflow. And then we do, for the system, rely on a nominal amount of bulk water being delivered throughout the year. Those yellow bars are weekly deliveries that would come to the site from the Nanaimo water system. And they would be 1 truck or 2 trucks to top up the cisterns. Now, there's always a variability when you're doing these designs on how much storage you make and how much rainfall is available. And if you had infinite space and cost available, you could make a large enough cistern to capture the water. But in this case, we found the happy medium, which worked for site. I just want to point out, I've got kind of highlighted in the center of this graph, you will see a black line traversing kind of along, and then I've highlighted here in the middle, in the dip, the summer months. That's when the children are not in school. There's a small amount of summer camps which will happen, but it's the low water use period. And sure enough, also it is the lowest rainfall period, which really made the difference between this commercial project being viable for rainwater and other projects that might have full occupancy year round. So schools are actually very well matched to the rainfall profiles that we're seeing, especially because we're getting drier and drier summers. And if we can have less water use during those times, then it works well. So just really high level, quick, I'm going to snapshot you through the system. So the new building, you'll see the blue colored roof there. That is a brand new roof, and that is what we're using as potable water catchment, around 1,500 meters squared there. That gets captured down through rainwater leaders, which then traverse to the storage, raw water storage in various tanks underneath the building, which for this project as well, it was unique and available to have this underneath the building space, which is protected from the weather. It is out of the sight and tamper possibilities from the children or any passersby. So that worked out very well. You see the green roof is the existing building. It was important for Montessori to do their irrigation with rainwater. They didn't want to use any potable water for the irrigation. And so we separated the existing building roof into separate untreated tanks to also lower the duty on the treatment system. And then going inside the building, when you have your own water system, of course, you need your own treatment for that system. It's quite a complicated system. But I'll just kind of give you an idea. We had some filters that just take out any sediments, followed by a UV sterilization system. And then the water would circulate and have a chlorine injection for residual. Now, often projects that have a very conscious environmental impact concern, they don't want to have chlorine in their water. But reality is, anytime you have stored drinking water, in this case, we have 3 days worth of stored treated water as a resilience kind of mandate, then the chlorine residual is required. So we have a circulating system and then distribution there. Oh, just one more little bit, go back. This came as an add-on. On the far right of this picture, you see the analyzer water recapture system. So when you have a rainwater catching system, you don't want any water just to continually be trickling to drain. And in order to have a robust system, we needed to continually analyze the chlorine content and the pH of the water. And that is a flow through analyzer system. So we have that probe in the analyzer, the water flows through, and we put that back into the tank. So that was a kind of neat added on feature. And finally, I just wanted to touch on also that in the beginning of this project, we thought when budget wasn't as much of a forefront, we were looking at design principles and water use and really how can we reduce the water volumes so that we can maximize the rainwater capture. We were going to consider the gray water system. So we would take the water from the lavatories, the sinks, and the sinks in the kitchens in the classrooms, and we were going to have a separate treatment system and have that be gray water to distribute to the toilets. So unfortunately, due to cost management, the completeness of the system was not installed, but we still separated all of the drain pipes underneath the building. You can kind of see in pink there, we've got multiple drain pipes running underneath the building, and it is ready to have that system installed. If one day water is more of a concern and they want to add that in, it is gray water ready building.
Amazing. Thanks,
yeah.
Sharon. And as a closing thought overall, so we obviously put a lot of focus on carbon for the project, but we know that that's not, and trying to bring it back to, you know, how this is all interconnected. If we're thinking about using, so this image is from the Stockholm Resilience Center. It's the subject really of a movie on Netflix called Breaking Boundaries. But this is the concept of the planetary boundaries. So, you know, on here, there's definitely carbon dioxide and water. But the LCA that was done for Discover Montessori didn't just look at those things. It was also looking at acidification, eutrophication, ozone depletion, smog potential, and primary energy. And then if we're thinking about this, one of the things that's, I think, quite exciting about having embodied carbon analysis done on projects is we're also generally getting to the point where we're not just mapping one of these planetary boundaries, but we're trying to map nearly half of them. So with that, I know we have less time than anticipated for Q&A, but we're happy to take any questions.
Thank you, Jeremy. Thanks, Sharon. Thank you, Ben. Really, really great presentation, and you know, it's very clear why this project would get recognition for all the efforts that you put into reducing carbon and just having all these sustainability, you know, aspects to it. So, I'm just looking at the chat to see if I didn't notice any. Oh, I'm not able to see that right now, but I mean, I can. There it is. I'm happy to open the floor to anybody who wants to ask a question first, and I can even I'll start us off if that's okay. But you know, calling back to the Douglas fir flooring that you were able to reclaim from Heritage Lumber, I'm curious. So a couple of parts about that. One of them was about the modeling limitations with it. My understanding of CAGBC zero carbon standard is that you do not need to model any, like you are only required to model new materials. Now I'm trying to see if that's just from the version 3 or if that was always like version 2 as well. But if that's the case, does that mean that that was a benefit to your project? Is that material you didn't have to model it? Or were you saying that you modeled something anyways, but it wasn't? Okay, so
yeah. we modeled it. We just didn't model the value of reclaiming using reclaimed material.
I see. Okay,
so we were conservative.
Yeah. Okay. Awesome. And then maybe this is a question more for Ben. When it gets to that the procurement of reused materials, how does that play out during, you know, throughout the project? How do you know that that's what you want to do to making sure that you actually are able to secure that material?
Yeah, it's a good question. It was an idea that we brought to the project very early, and you know, I went out to Heritage Lumber and met with the great people there and looked at the material. I had a lot of doubts about it, and so it's something that we kind of looked at early. But I got a lot of confidence from the folks there, and saw some samples, and and it's a beautiful material, so it was an easy sell to the client as well. And it was, you know, regardless of, you know, its impact on the model, you know, I think we all can, you know, see that it would have a positive impact on the carbon footprint of the project. But it was also, you know, the client fell in love with it just as much as I did. So.
Sorry, I think I accidentally muted you when I meant to unmute me. But yes, thank you for that. Does that mean that you went and looked at the material and then decided what to design after seeing the material, instead of trying to design something and find the materials that would work for your design?
Yeah, kind of. When looked at the material, you know, I was trying to assess like how, you know, rough and kind of it would kind of appear. That's why we arranged it in we had the vertical flashing between all the segments so that we could cut it down to a length that we could use without a lot of scrap, and it also kind of controlled the appearance of it. It took the material which had the propensity to be kind of, you know, I guess rough or unrefined, and then kind of contain it.
Excellent, awesome. And also I see, was it Yuri and then Neheo are so Yuri, you're the structural engineer on the project? That's nice to see you.
Yes.
And Neheo is the project manager, right?
That's right.
And yeah, so please, if anybody has bigger questions, they can answer, but I'll pass it on, Ivan, if you want to maybe jump in with the next question.
Yeah, just looking at the chat here, there were maybe those weren't really reading them, but I guess some notable questions were about the reclaimed tile. That there was some discussion about that as far as where they were located in the building. It appears it was just on the interior rather than exterior. Yeah, other things here was just looking at here about. A question was posed in the chat here. Would the team be considering pursuing living building challenge with this? And maybe I know Ben did answer that, but could you care to elaborate a little bit more in terms of consideration, and maybe was this even a thought at the beginning, or was it something that, you know, now you're kind of thinking about it?
Yeah, I mean, we're thinking about it now, I guess, but you know, the one thing to talk about is, you know, when you talk about the overall cost on a project with a very tight budget, you know, these certification programs cost money, you know, so that's something to be considered, you know. But and it's also, I don't know as much as I should about the Living Building Challenge, but I have the impression that there's a lot to checking off all the boxes in that certification program, and we really had to focus our time and our resources.
Yeah, and that's we've seen that in our projects too, where less so on the Living Building Challenge, but more even on passive house buildings, where they were just like, it's a lot of hoops to jump through. And really, we just want to do good. So we're probably, if we have resources, let's just direct on doing better and lowering emissions rather than kind of get that plaque on the wall. So
exactly.
Yeah.
Yeah, I could maybe add to that with Living Building Challenge. I think there's a lot more scrutiny about the materials, especially that you are or cannot use, because there's a lot more requirements about you know, the lack of pollution and all that. So it would definitely, like Ben said, would just add probably a lot of cost to the project. Like the comment was, we could probably make it if the process was a little bit easier, but yeah, it's definitely you know, sort of a challenge.
Hey, Yuri, did you want to say something?
Yeah, I just want to mention something that we didn't talk about this today just yet. As a quick shout out to the contractor on board. I think there are two things. First of all, they were open-minded to our design decisions, all of that stuff, retaining walls, architectural stuff, piers. They were supporting on that, and because they taking liability on that as well. And the second thing, having them early in this case, we have them very early on board, prior to construction, have the input and being able to incorporate it and make it happen as a real project was a big part of the success.
Yeah, and the contractor, good point, Yuri. The contractor was Tectonica out of Nanaimo. And yeah, they were they were on board just like everybody else on the team. They were really supportive of the project.
All right, great. Thank you. I mean, I see that we're already past the hour now. So I don't know if anybody has any burning questions. I know, Jeremy, you mentioned that you don't have a hard stop, but if anybody wants to maybe jump on, feel free to unmute yourself and ask a question. Otherwise, I'll have some kind of closing notes.
Stephanie, why don't you do the closing notes, and then we'll stay past it.
Sure. Okay. Excellent. All right. So, yeah. So, thanks again to each of you for coming today, to speak to everyone, and even for the additional project team members to want to join today to be able to answer some questions. Big thanks to Ivan for helping me with, moderating all this, and of course Roberto and Gordon in the back end, kind of managing all of this. So, thank you. The next thing I'll say is we don't have a webinar similar to this next month, but we do have BuildX that will be, there will be 4 presentations that are hosted by CLF BC, but various presenters from different organizations and practices. There are 4 altogether with really great themes. It's all of those 4 will be on the Wednesday, February 14th. So I definitely encourage you to take a look at that. Stay tuned. You'll get an email after this webinar early next week with a link to the webinar and the presentation slides, I believe, as well. And the newsletter for this month will also be going out next month. So you'll see it linked there if you missed it in your inbox. And lastly, also at the end of the BuildX, the day 1, February 14th, we'll have a social for CLF BC. So I think we'll hold it at Lions Pub, which is on Cordova Street. So I hope that I will see you guys there. And other than that, I think that's it for my remarks. And we can just stick on if anybody wants to ask some questions, but otherwise feel free to jump in and grab your lunch if that's what you need right now.